Hello guys, and welcome back to Entrep Energy Talk. I'm your host Tamerlan, and today we're diving into fascinating work of nanotech. Nanotech has always been a concept, but now we realize some of those things. And today I've invited Mr. Amit, who is a specialist in that area. Mr. Amit, welcome to the show. Thanks for joining us, and can you please tell us something about yourself?
Thank you for the invitation, first of all. So, I'm Amit, and I'm a material scientist in the laboratory of Nanomaterials in Skolkava. So, my journey as a scientist started very long time ago, I believe, from 2015, when I was used to be a bachelor student. And from them, I'm seeker of science.
As all of us know, nanotech is a billion-dollar industry, starting from healthcare, and it's everywhere. And can you please tell us why is it so unique?
So usually when we talk about nanotechnology developed using like nanomaterials, and how we characterize nanomaterials. So nanomaterials are materials who having like specific size range from 1 nanometer to 100 nanometers. And when you put like any material in this nanoscale, their specific surface area, and their properties enhanced. They enhance 1,000 times. For example, like you can take a cube, you cut it in multiple times or billions of times to make in a nano size. So every time you make a cut, you increasing its surface area. And this surface area on some certain levels, like of this ordinary materials, they possess some unique surface properties. And these properties are very useful for nanotechnology. And that's how those properties we use to create nanotech and make the changes.
So nanotech's all a thin surface area.
Yeah, like surface area. As you reduce the size, the surface area, their other properties, their strength, physical or chemical, they all changes, they all alter. For example, if you ever like seen or not, if you see golden nanoparticles, they are not in a golden color which you see in ordinary life, but they having like so many applications when you turn gold into nanoparticles and people use them.
Yeah, that's very fascinating. I mean,
Yeah.
never thought about it that deep.
Yeah, so with respect of time, people realize, scientists realize how this reducing size of matter affect the world, affect the technology, and how we can use this those properties in the application, in real world applications. So for example, 20 or 30 years ago, when we used to have like telephone, this was like this size. Now we have like a machine called smartphone. We can do most of things in this size. So this is all we can contribute it to this nanotechnology. Things getting smaller and smaller with the same work efficiency which you had before, or maybe sometimes better than that.
So making analogy to the business area, now evolving businesses, they can use nanomaterials for making their products more strong, durable, lighter, or can they be more effective at some point?
Yes, they do. Nowadays, there are so many startups, tech companies which are using nanotechnology to make such products. For example, in the company Tesla, they use nano coatings to increase the durability in their products. IBM is working on graphene-based screens, which also increase the strength of touch screens and durability. Some companies also synthesizing about using nanotech to create more advanced level of electronics, such as sensors. For example, in my lab, we also worked on some gas sensors based on carbon nanomaterials, and these gas sensors are more effective than ordinary sensors.
Why are they more effective?
So they are more effective just because on nanoscale their sensitivity is too high in comparison to ordinary one.
So you think the future is after those technologies?
Yeah, so like, look, in a small size, I can give you like very good example. Yeah, if you have something in a bulk of like 1 kg, you need a force to make it feel some resistance for this. But when this thing is like 1 gram, then your energy requirement for the sensitivity decrease. So resistivity decreased. So that's how nanotech works.
Yeah, that's impressive.
So their efficiency is enhanced when they are going to be like a smaller size, as I stated earlier.
So smaller size means less mass, which leads to less force.
Yeah,
that's impressive.
For example, few years ago, Samsung started some new class of televisions, yeah, with like they call QLEDs. QLEDs, like how to say, they define like quantum LEDs, and these quantum LEDs are more energy efficient in comparison to other LCDs and other ordinary TVs.
Yeah, I heard about this. It's impressive. I also read an article. So going to our next question, manufacturing at nanoscale. In my opinion, as I understand it, it will decrease cost, be more efficient, and just be a breakthrough in today's realities. Can you please explain why it is so?
So, first of all, like if we talk about business, so for business model, always the cost reduction is matter. It's like more prominent goal for like any business. So in nanotechnology, of course, we can say there is a hurdle for the precision. But once you set this precision, like using your R&D department, research and development, once you settle down everything, then it reduces the cost of production significantly.
Yeah.
So because you can just have to make efforts like few times and you are good to go.
Yeah, so just more movement which you need to make. So
yeah, so in the very beginning it's hard. So
because
I believe like this is the simple rule, like always beginning is a bit hard, tough, and then life is easy.
Yeah, because
the same work on nanomaterials and nanotechnologies as well.
Yeah, because at the beginning it requires a lot of investment just to start the project.
Yes.
And then it just goes slightly easier.
Of course. And in the beginnings you have to see like in the business perspective, failures, success, small success, or like sometimes bankruptcy as well in some cases, especially with the new startups. But once they achieve like significant precision in their product or in their technology, then they got a very good hype.
Yeah, because for new startups, it's difficult in the market because there's huge firms.
Well, for the market, they having like another kind of subjects. Like you need to promote your technology. You have to explain everybody like why your technology is better than them. Also, there is a problem with the nanotech. Like people are conscious about their hazards, their toxicity. So you need to like think about that as well. Well, there is some certain departments who are working for like to analyze toxicity and some hazards using this nanotech. And if everything's safe to go, then the industry boosts up.
Yeah, got it. Thank you. Yeah. And one more aspect which is very interesting for me, because recently I started using 3D technology by printing something what's needed for my other projects. And do you think that nanotechnology and 3D printing could be combined? So can you make something nano from 3D printing?
Right now it's not accessible, I will say, but it's not like impossible to do. And if we achieve this nano 3D printing, it will reduce the waste from this like kind of a scale of printing. And this reduction of waste also very sustainable in nature, I believe say. So nanotechnology, like in this concern, we can say nanotechnology not offer like a good deals with like people's comfort. Also, it provides a sustainable approach as well.
Yeah, just as I said, reduces waste, which is essential in the reality.
Yes.
So
also, any kind of printers, they produce some kind of waste such as CO2 emissions and aerosol emissions. So if you use like some kind of a nanotech based of like 3D printing or like 3D printing of nanoscale, it also reduce such kind of a waste, such kind of emissions.
Yeah, that's what we're talking about. One topic which you mentioned is sustainability, and I think it's actually a very important aspect today. Can nanotechnology help to improve the sustainability?
Of course, nanotechnology do. From last 3 years, I'm working on a project of carbon capture using carbon-based nanomaterials. So why particular carbon-based nanomaterials? Because carbon-based nanomaterials are more sustainable in nature. They can easily decompose as well. So, for instance, I can give you the example of my own research. I'm using carbon nanotubes to capture carbon dioxide. And these carbon nanotubes, they absorb carbon dioxide more efficiently than conventional carbon capture methods, and their energy requirements are also very low. So usually in carbon capture field, the intense energy required to deabsorb the carbon dioxide from the surface of any material. And if you reduce such energy requirement, you reduce the cost. So using such nanomaterials, which I am working on, they reduce significant cost, because for desorption of this carbon dioxide from its surface, it's easy. It requires like very less energy. So that's how, at the same time, I'm making a solution for ecology, like reducing carbon emissions, and at the same time I'm reducing the waste product and or using a product which can be biodegradable in nature. So we take care of sustainability, ecology and technology at the same time.
So carbon dioxide is actually everywhere.
Yeah, of course, everybody produces carbon dioxide.
Even electric cars?
Anything.
Anything.
So wherever you use oxygen, wherever you use fuel, you produce carbon dioxide, since all matter is from carbon. So, and in our earth, the life is sustained because of oxygen, yeah. So, and carbon. So they always creating some chemical junctions where they produce carbon emissions. So on every single step, we as humans, we also produce, like in our breath, carbon dioxide every day, in every second, yeah.
Yeah, I got it. Thank you. That's actually something to think about, that we cannot deal with carbon dioxide unless we have methods which we don't have now.
Well, the methods to deal with the carbon dioxide is not new, but they are not that much popular until unless like we started to feel the major problem of global warming and climate change. And once like everybody started to face such kind of a problem, that soil erosion, somewhere like flood, tornadoes, and increasing the temperature in world. So we started to admire those technology, and then we try to improve those technologies. So before that, people used like liquid amines, for example, to capture carbon dioxide. But now people are moving towards like more sustainable, more efficient adsorbents. So that's how we are implying nanotech to make such kind of a progress in our work.
Can we consider nanotech as a renewable source, renewable material? So can renewable?
We can consider, but it's also matter of debate as well, because some types of materials, they are not that much sustainable or degradable. So they're having like some hazards, but this kind of problems also can be solved with respect of like research and their proper outcomes. So in world, not only me, like a lot of scientists are working on such solutions. Like few months ago, I read an article where scientists in Australia, they developed some kind of a viruses who combat with the polythene, to degrade polythene.
Yeah.
So such kind of technologies with like evidence of like scientific progress, where we also developing like in various fields like biotechnology. So biotechnology is also very parallel to the nanotechnology.
Yeah, I heard that biotechnology is now developing.
Yeah, so
So diving a bit into the risks now. If we're talking about nanotech, are there any risks maybe about the nanoparticles which can be in the air or anything else? Can you develop on that, please?
well, nanotech always said to be like a risky profession or risky field, but it's not like very how to say, good to say. It's the risk always limited up to the laboratories, not like out of laboratory. When you make any technology and when this finished good come to the market, there are institutions which ensure this kind of how to say safety for the public and other consumers of the nanotech. For example, nano materials or nano size of any element, they can easily go inside our body, penetrate our lungs.
So that could be dangerous.
Yeah, that can be dangerous. But on other hands, such dangers are not in public. They are just limited up to laboratories, but we can't ignore them as well, because a few years ago we encountered COVID. That is also a kind of a lab leakage. So sometimes scientists ensure things, or most of times they ensure things of like safety reasons, of like public health and other health. But if we see just only the cons of any concept, then we can't progress. So we always have to focus on pros as well. So nanotechnology, sometimes they are a bit suspicious and can have health hazards, but they having a lot of advantages as well.
That brings me to the concept of quantum sensors. Can they somehow identify those particles and make it more safe to use them?
Yes, there are a few setups, or I can say few technologies, which also used to detect spread of such nanoparticles or nano health hazards. And these kind of specialized products, they quantify these nanoparticles and they try to give us more safety. In our laboratory as well, we use like some kind of a machines called CPC, and those machines used to count how much nanoparticles in per liter of air or per liter of volume.
So there is some limit which is allowed for limit how many particles should be in like one liter volume.
Well, it's depend on like what kind of a material you are using. Like some of materials where you don't concern about limit up to like some certain level, and some of materials they are even like so dangerous in like very less quantity as well. So it always depends.
Thank you. So the next question about scalability, because as you mentioned, now nanotech is only in a lab, so it's difficult for businesses to measure the profit which they will gain from it. And is there any, from a physics viewpoint, is there any opportunity to scale it?
Well, I will not say like most of nanotech in the lab, but I will say nanotech development is in progress in the labs, but they are also in the market, as we see in our everyday life. Like for example, the big companies such as Tesla, IBM, Google, Nvidia, they all are working on nanotechnologies, and we see the market are flourishing for them. And these company making like huge revenue in comparison to ordinary industries. So you see the nanotechnology having like a very good potential. Just we have to find a good applications, a user-friendly application of those nanotechnology, and you can flourish your business and entrepreneur.
So diving into the future, some people predict that nanotech will be as essential as AI, for example, or blockchain for businesses. From physics viewpoint, what do you think about it? Will it be as essential as AI now?
Well, I would say I would like to comment it in another way. For example, as you mentioned, AI and these other things. So somehow they are also part of nanotechnology. Those chips which we are using, they are based on nanotechnology. For example, nowadays people appreciate NVIDIA's cards, and these cards are based on technology, for example, processor of size 3 nanometer, 2 nanometers. So they are also the part of nanotechnology. So as AI and other other technologies we are using, so nanotechnology is a part of them, not like separate. So as those things evolve, the nanotechnology is also evolving.
Mr. Ahmed, that was a fascinating discussion. Do you have any final thoughts on the potential of nanotech?
Yeah, for the newcomers, I would like to say nanotechnology is the future, and it's having like very nice potential to grow as a businessman, as a scientist, in both prospects. So believe in nanotechnology and go ahead.
Yeah, it's future for sure.
Yeah.
Yeah.
So thank you so much.
Yeah, thank you.
Yeah.